Hey kids, it's Dr. Rones here. We are starting a new chapter and it's going to be fabulous. This is a good one on inequalities. And so this is a lot of information to take in. A lot of it's new, so we are just going to break it off in little pieces as we go, just a bite at a time. Just a disclaimer before we get started, of course, you know I do my very best so that these are helpful for you at home, but they're not going to be perfect. Other math teachers might teach this a different way, and that's totally fine. These are just the highlights and stuff to get you through in case you need a recap of the lesson or you miss a lesson entirely from an absence or something similar. So here we go. Let's jump in. Let's please define some of our inequalities here. So for example, all numbers that are less than 2. So when we write an inequality, we'll write our variable first, and then the number that we are comparing it to the right, and then less than is like so. You may recall the alligator from your past. I hope we have moved beyond the alligator, but if we have not, it doesn't hurt to write something like this at the top of your page, and even the backwards would be fine too. Okay, so all real numbers that are less than on the smaller side of 2. And so when we graph this, we only need to make a solid horizontal line with a tick mark in the middle with the 2, and for greater than or less than, these two symbols, we make an open circle because the solution does not include 2, but it's everything less than 2. Let's try another one. All real numbers greater than 2. Greater than, it's on the bigger side of 2. And so similar to less than, we'll do an open circle because the value does not include 2, but it's all the numbers to the right. And so graphing for inequalities is quite simple until we start graphing equations. Okay, so now we have all real numbers less than or equal to. So this is a new sign you may not have seen before. So there's our variable, and there's our 2, less than, or equal to. Imagine this is like the bottom of an equal sign, right? But it's not equals, it's less than or equal to. When you are doing less than or equal to, greater than or equal to, this is going to be a closed circle because the solution could include 2 and as well all the numbers below it. So all real numbers greater than or equal to 2, try that one. All real numbers in 2, they're on the greater side or equal to. So it's like an equal sign only with a greater than on the top. It includes 2 and all the numbers above. Something that may be helpful for you moving forward, as long as the variable comes first in the expression, the direction of the inequality sign shows the direction of the arrow. So this is pointing left, this is pointing left, this is pointing right, this is pointing right. So this almost looks like the arrow, right? That's a little trick that maybe helps some students until they really master that skill on their own. Okay. So, of course, we're not just going to leave it there. We are going to solve some simple inequalities. And before we flip the page and work on that, this is the big idea. The process is very similar, almost the same, to solving the equation, except when we multiply or divide by a negative, we'll flip the sign. Again, anytime we have to multiply or divide by a negative, we flip the sign. If we multiply or divide by a positive, we don't have to flip the sign. If we add or subtract a negative, we don't flip the sign. It's only the operations of multiply and divide, specifically with a negative. Okay. All right, let's do some work here. This is going to be great. And so as we go here, I'm going to teach you both how to solve a simple inequality, how to graph it, and then how to check your work, because as we're learning these skills, it's important that you know how to check yourself for accuracy. So we have some value, and 5 is greater than or equal to 3. Now, you probably could already tell me that -2 and 5 are greater than or equal to 3. but this is going to get way more complicated. So let's learn the rules of how to solve this so we can apply it to a more complex situation. So just like solving an equation, we want to isolate x. The reverse of a positive 5 is a negative 5. What I do on one side, I do to the other. So x is something negative 2. 3 minus 5 is negative 2. I did not multiply or divide, so I don't need to worry about flipping the sign. So x is greater than or equal to negative 2. So for the graph, we draw a horizontal line with a line in the middle. I've done that for you. You're welcome. With a negative 2. Is it going to be an open circle or a filled in circle? It's going to be filled in because it can include negative 2 as well as all of the numbers that are greater than it. Okay, so we would write our solution like so. Just like we did in solving equations, we always write the variable first. Okay, and now we're going to check our solution. So I suggest choosing any number that is greater than or equal to negative 2. When possible, I like to use the number 0. It just makes things a lot easier. So is 0 greater than negative 2? Yes, it is. Well, that's very convenient. So let's try 0 because it's greater than or equal to negative 2. So that means if I have the equation x plus 5 is greater than or equal to 3, I should be able to say 0 plus 5 is greater than or equal to 3. 0 and 5, of course, is 5, and that is greater than 3. So we're good. Great. I know that's a simple skill and a simple equation, but as this gets more complex, that will be very helpful for you to have made part of your habit in solving. Okay. All right, let's try another. Go a step ahead of me, see what you can do independently. Isolate x by adding 7 to each side. The reverse of negative 7 is positive 7. What I do on one side, I do to the other. X something 11. I did not multiply or divide, so I don't need to worry about flipping the sign. So x is greater than 11. Okay, go ahead and graph. 11 was our solution. It's greater than, so it's an open circle because it doesn't include the number 11, just all the numbers greater than it. An arrow to the right, because this arrow points that direction. This variable is first, so that works. Okay, so let's pick a number that's greater than x. Oh, we can't do 0, can we? Let's just try 20. 20 is greater than 11. So that means I should, instead of saying x minus 7 is greater than 4, I'm going to try 20 minus 7 is greater than 4. It really doesn't matter what number you choose. 20 minus 7 is 13, and that is greater than 4. I just said it doesn't matter what number you choose. I should say it doesn't matter what number you choose as long as it's greater than 11. Okay, so you cannot choose 11 here because it's greater than, not greater than or equal to. Here I could have chosen negative 2 because the solution was greater than or equal to negative 2. Okay, so let's step it up here. You know this one's right. So here we want to isolate x. Negative 2 x's are greater than negative 6. To isolate x, we will divide by negative 2. What I do on one side, I do to the other. Negative 2 over negative 2 is 1. X is something negative 3. Now I divided by a negative. Because it's both division and involved a negative, then I switch the sign. So it was greater than, now it's going to be less than or equal to. That negative, just flip the direction. It undid our the sign on the original number. So we can graph this, negative 3, filled in because it's less than or equal to, and we go to the left. And so we can check our solution. If you can do this mentally, that's totally fine. So if I have x is less than or equal to negative 3, I could choose negative 10, couldn't I? Negative 10 is less than, okay. Negative 10 times negative 2 is 20. 20 is greater than 6, so that works too. So you don't have to write out all those steps. If you can do that mentally, that's totally fine. Okay. Now, does it matter if you forget to switch the sign? Yeah, it does. If I had forgotten to switch the sign, I would have had x is greater than or equal to -3. And that would have given me all of the incorrect answers, except for, I guess, -3. But all the other numbers greater than -3 are incorrect. So by forgetting to switch the sign, you are in essence getting all the wrong answers, unfortunately. Okay, let's try this one. We want x by itself. It's being divided by a -7. The reverse of division is multiplication. What I do on one side, I do to the other. X is something, -21. Okay, the rule is if I multiply or divide by a negative number, I multiplied by a negative number, then I switch the sign. So -21 is what I graph. Is it an open or a closed circle? Open. Less than. All the numbers less than -21. So let's try, what's a multiple? Let's say -28. I'm looking for something that's a multiple of 7. -28 divided by -7 is 4, and 4 is greater than 13. 3, not 13. And so we know that that is correct. All right, hopefully that made sense to you. If it did not, of course, before you jump into your homework, maybe go back, rewatch, double check to make sure that you understand what you're doing. And so we have some fabulous practice for you. It's going to be great. You guys are going to love this chapter, actually. This is just the beginning of a fabulous experience. It's going to be great. Okay. So numbers 1 through 4 are asking you to write a verbal phrase that describes the inequality. I would refer to the first page of your notes, these statements here. Of course, they're not all going to be 2. They're going to be a different number. So that I'm not stealing, I don't have one of those on the front. So I guess I will do one of these. So x represents all real numbers. And what does that sign mean? Greater than 5. Okay, it's a lot to squeeze in there. It'll be okay. I have laser vision. I'll be able to see it. Okay, now we're going to write an inequality that corresponds with the graph. These I have extras on the back, so we'll use these. Okay, so for example, try number 1. We're doing x and 1. Because this is where the circle is. Okay, because it's an open circle and the the arrow is going to the left, what is my sign? Less than. See, I'm choosing all the numbers that are less than 1. Less than. Is it or equal to? No, it's just less than. If it were filled in, it would be less than or equal to, but because it's open, it's just less than. Okay? All right, so this is what your solution should look like. Okay, for number 9 through 14, you're just flipping that skill. Remember, I recommend that you write the variable first, but when you do that, x was greater than 4. So when you flip that, you can't just keep the sign the same. X still needs to be on the greater side of positive 4, sorry. So when you graph that, you need to consider, there's your line, there's the little mark, 4 goes there. Okay, is it an open or a closed circle? It's open, because it does not include 4. In which direction does the arrow go? If x is greater than 4. X is greater than 4. Corresponds with the direction of the inequality sign. Okay. 15 through 26 should be just like solving normal equations except for the one rule. If you multiply or divide by a negative, then flip the sign. If you multiply or divide by a negative, then flip the sign. Now, if you are someone who does just fine with mental math, feel free to do mental math. However, I strongly recommend that you check your work when you are done, because that small skill of remembering to flip the sign when you multiply and divide by a negative, sometimes goofs people up. They get the right number solution, but they get the wrong inequality sign. All right, let's do an example though, just for fun. I have some more room for 26, so I'm just going to do number 26. Okay, I have a negative x over 2. So x is being divided by a 2. The reverse of division is multiplication. Let's get that negative taken care of as well. What I do to one side, I do to the other. Of course, you would do this work on lined paper, but I don't have that luxury at the moment. 26. Did I just multiply or divide by a negative? Yes, I multiplied by a negative, so I'm going to flip the sign. Okay. Now what's wrong with my solution? Yeah, the variable needs to come first. I can't just flip it and keep the sign. X was on the lesser side of the arrow. X should be on the less side. So that's the inequality that you would write on the worksheet, as well as negative 28. Is that going to be a filled in or open circle? Filled in, and that way. And then of course you can test your work. So let's see, negative 50 is closer, no, negative 50 is less than negative 28. Negative 50 divided by negative 2 is positive 25, and positive 25 is greater than 14. So that's good. We got it. All right, yes, I'm giving you word problems. They're great. These are very practical for you. It says, let's look at the stereo. You need at least $25 more to buy a stereo system. Write an inequality that describes how much money you need as S. For these, if you want to change them to X, you can. I have a problem where my 5s tend to look like S's, so I tend to change them to X. You do whatever you want. So I'm comparing the variable and $25. I need at least $25 more. So is 25 going to be good enough? Yeah. So it's going to be or equal to, okay, I need $25 or $26 or $27, and all of these are greater than 25. And so that's why it's X is greater than or equal to 25. And that can be the end of that. So I hope that was helpful to you. Of course, if it's not, I'm always happy to help. You can shoot me an email here. And I can help you through email. Otherwise, I will see you in class. Thanks, guys, and we'll see you soon. Bye.